Lesson 6.3 is on polynomials. In this lesson, we will classify polynomials and write polynomials in standard form, and then we'll evaluate polynomial expressions. So first we're going to start with monomials. A monomial is a number, a variable, or a product of numbers and variables with whole number exponents. So for some examples, we have 5x, negative 7xy, 0.5x to the fourth. Some non-examples that are not monomials, negative 0.3x to the negative second, 4x minus y, and 2 divided by x to the third power. They have to be positive exponents, and they have to be one term. This is more than one term. So the degree of a monomial is the sum of the exponents of the variables. A constant has a degree of 0. So we're going to go ahead and start with example 1 by looking at and finding the degree of a monomial. So in A, we have negative 2, a to the second, b to the fourth. Negative 2 is a constant, so it has a degree of 0. A to the second, degree of 2, because the exponent's 2. B to the fourth, the exponent is 4, so that is the degree. And then to get the degree of the monomial, I add 0, 2, and 4 together to get 6. So the degree for the monomial is 6. 4 is a constant, so that means it has a degree of 0. So the degree of the monomial is 0. 8y, 8 is a constant, so the degree is 0. Y, the degree is 1. 0 plus 1 gives me 1. So the degree for the monomial 8y is 1. There are 3 examples at the bottom, so go ahead, take a moment, pause the video, and try this one on your own. 1.5 k squared m. 1.5 has a degree of 0, k squared, degree of 2, m has a degree of 1. Add them all together, you get 3. So the degree is 3. 4x, 4 has a degree of 0, x has a degree of 1. 0 plus 1 gives us 1. Last one, 2c cubed. 2 is a constant, degree of 0. C cubed has a degree of 3. And 0 plus 3 gives us a degree of 3 for the monomial. So now we're going to continue on and look at polynomials. A polynomial is a monomial or a sum or difference of monomials. The degree of a polynomial is the degree of the term with the greatest degree. Remember, the terms of an expression are the parts being added or subtracted. So terms are separated by addition or subtraction. So here we are going to find the degree of a polynomial. So we're going to look at each individual monomial, identify the degree, and whatever monomial has the greatest degree, that is the degree of the polynomial. So first we're going to look at A, which is 4x minus 18 to the fifth power. 4 has a degree of 0, x has a degree of 1. So the monomial 4x has a degree of 1. 18x to the fifth. 18 is a constant, so it has a degree of 0. X to the fifth has a degree of 5. So the whole monomial has a degree of 5. Now to determine the degree of the polynomial, we look for the greatest degree of the monomials. So 5 is the greatest, so that means the degree of the polynomial is 5. Example B, we have 0.5x squared y plus 0.25xy plus 0.75. 0.5x squared y, 0.5 has a degree of 0, x squared is 2, y is 1. So 0 plus 2 plus 1 gives us a degree of 3 for that monomial. 0.25y, 0.25 has a degree of 0, x1, y1. So 0 plus 1 gives us 2. And then 0.75 has a degree of 0. The largest degree is 3. So that means the degree of the polynomial is 3. C, 6x to the fourth, 9x squared minus x plus 3. 6x to the fourth has a degree of 4. 9x squared, a degree of 2. X, a degree of 1. 3, a degree of 0. So the largest degree, or the greatest degree, is 4. So that means the degree of the polynomial is 4. There are 2 check it out problems for you to try, so go ahead, take a moment, pause the video, and then resume when you're ready to check your answer. 5x minus 6. 5x has a degree of 1. 6 has a degree of 0. So the degree of the polynomial is 1. B, we have x to the third, y to the second, plus x to the second, y to the third, minus x to the fourth, plus 2. X to the third, y to the second has a degree of 5. X to the second, y to the third has a degree of 5. X to the fourth, degree of 4. And then 2 has a degree of 0. So the degree for this polynomial, the biggest is 5. So the degree for the polynomial is 5. So now we're going to go ahead and look at example 3. So the terms in a polynomial may be written in any order. However, polynomials that contain only one variable are usually written in standard form. So in this example, we're going to look at how to write polynomials in standard form. The standard form of a polynomial that contains one variable is written with the terms in order from greatest degree, so the highest exponent, to the least degree, to the smallest exponent. When written in standard form, the coefficient of the first term is called the leading coefficient. So for example 3, we're going to write each polynomial in standard form, then give the leading coefficient. So we're going to order the variables exponents from greatest to least. Constants will be the last part. So I have 20x minus 4x cubed plus 2 minus x cubed, or squared, sorry, minus x squared. So the greatest exponent, so I have 1, 3, and 2. 3 is the biggest. So don't forget, subtraction is going to mean that term's negative, so you need to bring it with it. So it's going to be negative 4x cubed. So that term is used. So you can cross that out if you want, so you remember you used it. Then x squared, but it's minus x squared, so minus x squared. And then I have 20x, so plus 20x. And then the constant is 2, so plus 2. So the full polynomial written in standard form is negative 4x cubed minus x squared plus 20x plus 2. And then the leading coefficient is the coefficient of the first term, which is negative 4. So the leading coefficient is negative 4. B, I have y cubed plus y to the fifth plus 4y. The biggest exponent is y to the fifth. Then y cubed, so plus y cubed, plus 4y. And then for this example, the leading coefficient, we have to look at our first term. Our first term here is this y to the fifth. So the coefficient of y to the fifth is 1. Normally we don't write 1, but there is technically a 1 there. So that is our leading coefficient. Our leading coefficient is 1. There are two check it out problems at the bottom. Write each polynomial in standard form, then give the leading coefficient. So go ahead, take a moment, pause the video, and try this one on your own, and then resume when you're ready to check your answer. So for 3a, we have 16 minus 4x squared plus x to the fifth plus 9x cubed. So the largest exponent is 5. So I'm going to write that term first. So x to the fifth. Next would become cubed. So plus 9x cubed minus 4x squared and then plus 16. The leading coefficient here is the coefficient of the first term. And the first term is x to the fifth. So the leading coefficient is 1, because it's 1x to the fifth. 3b, I have 18y to the fifth minus 3y to the eighth plus 14y. 8 is the largest exponent, so that'll go first. So negative 3y to the eighth. And then 5 comes next, so plus 18y to the fifth. And last but not least, plus 14y. And then here, the leading coefficient is the coefficient of the first term. And the first term in this polynomial is negative y to the eighth. So the coefficient, the leading coefficient, is the negative 3. So that is how you write polynomials in standard form and identify the leading coefficient. So now we're going to look at example 4. Okay. In example 4, we're going to deal with classifying polynomials. Some of them have special names based on the degree and the number of terms that they have. So we're going to look at the specific names based on the degree and the terms. So for degree, 0 is a constant. A degree of 1 is linear. A degree of 2, quadratic. A degree of 3 is cubic, 4 is quartic, 5 is quintic, and then 6 or more, you just say it by the degree. So 6th degree, 7th degree, and so on. The number of terms in an expression, one term is a monomial, and we looked at that in example 1. 2 is a binomial, so 2 terms, bi means 2. 3 is a trinomial. Tri means 3, and then 4 or more terms is going to be a polynomial. Okay? Monomials, binomials, and trinomials are all polynomials, but they're just a specific label for a specific type of polynomial with those specific number of degrees. So for number 4, we're going to classify each polynomial according to its degree and number of terms. So first, we're going to look at the degree. Then the number of terms to help identify what kind of names we have. Okay? So our first example is 5x minus 6. X has a power of 1, so that's going to be a degree of 1, 6th degree of 0. So the largest degree is 1. So the degree is equal to 1. And then the number of terms I have, terms are separated by addition and subtraction, so the subtraction would break it into 1, 2 terms. So a degree of 1 means it's going to be linear, and then 2 terms, binomial. So linear, binomial. B, I have y squared plus y plus 4. The degree, the largest degree is going to be 2. And then I have 1, 2, 3 terms. So degree of 2 and 3 terms. A degree of 2 is a quadratic. So I have a quadratic. And then 3 terms is a trinomial. So I have a quadratic trinomial. C, I have 6x to the 7th. Plus 9x squared minus x plus 3. The degree is going to be 7. And then I have 1, 2, 3, 4 terms. So if I have a degree of 7 that's 6 or more, so I just say the 7th degree. And then 4 terms, 4 or more, we label as a polynomial. So this is going to be a 7th degree polynomial. There are a couple check it out problems at the bottom. There's 3 of them. So go ahead, take a moment, pause the video, and try these 3 on your own, and then resume when you're ready to check your answer. All right, so A, x cubed plus x squared minus x plus 2. The degree here is 3, and then there's 1, 2, 3, 4 terms. So if I have a 3rd degree, that's going to be cubic, and 4 terms is a polynomial. So this is a cubic polynomial. 6 is a constant. It has a degree of 0. So degree is 0, and then it's 1 term. So a degree of 0 is a constant, and then 1 term is a monomial. So it is a constant monomial. And then for C, we have negative y to the 8th plus 18y to the 5th plus 14y. The largest degree is 8, so the degree of the polynomial is 8. There are 1, 2, 3 terms. So if I have a degree of 8, 6 or more, you say it by the degree. So this is going to be the 8th degree. And 3 terms is called a trinomial. So 8th degree trinomial. So that is how you classify polynomials using the degree and the number of terms. So now we're going to go ahead and look at example 5. There's a physics application. It says a firework is launched from a platform 6 feet above the ground at a speed of 200 feet per second. The firework has a 5-second fuse. The height of the firework is given in feet by the polynomial negative 16t squared plus 200t plus 6, where t is time in seconds. How high will the firework be when it explodes? So we know it is a 5-second fuse, so that means t equals 5. So in this polynomial, we're going to replace t with 5. So negative 16 times 5 squared plus 200 times 5 plus 6. So 5 squared gives us 25. Then negative 16 times 25 is negative 400. 200 times 5 is 1,000. And then I have the plus 6. So negative 400 plus 1,000 plus 6 will give us 606. So when the firework explodes, it will be 606 feet above the ground. There is a check it out problem at the bottom for you to try. So go ahead, take a moment, pause the video, and then resume when you are ready to check your answer. So it says, what if another firework with a 5-second fuse is launched from the same platform with a speed of 400 feet per second? Its height is given by negative 16t squared plus 400t plus 6. How high will this firework be when it explodes? So our time t is going to be 5, and we're using the expression, or the polynomial, negative 16t squared plus 400t plus 6. So I'm replacing or substituting in 5 for t. So I'm going to have negative 16 times 5 squared plus 400 times 5 plus 6. 5 squared is 25, so I have negative 16 times 25 plus 400 times 5 plus 6. Negative 16 times 25 is negative 400, plus 400 times 5 will give us 2,000, and then plus 6. Negative 4,000 plus 2,000 plus 6 will give us 1,606. So how high will the firework be when it explodes? It'll be 1,606 feet above the ground.